Hello developers. Today we are going to build an AI-powered emoji detector. By the end of this video, you will have a working model that you can customize and use in your project. AI-powered emoji detectors can be used by companies to increase engagement with their customers. They can create personalized content for their users, which will help them in building a strong relationship with their customers. One of the most important aspects of AI-powered emoji detectors is that it will help you in detecting any kinds of emotions and expressions on your face or hand gestures from the web camera. You will also be able to build a similar AI solution today. We'll be using a Kandi kit to build this AI solution. So what is a Kandi kit? Kandi one-click install kits gives you a ready-to-deploy solution with a complete source code. You can access many more such ready-to-use Kandi kits on AI, augmented reality, gaming, blockchain, and many more on Kandi. Today, we'll be using a popular Kandi kit on AI-powered emoji detector one-click install kit. This kit is open source with a permissive license, which means you can freely edit, customize, and share your solution. So let's get started. Over to you, Ganesh, for the hands-on walkthrough.
Hello. Hope you are excited to build your own AI solution. To build an AI-powered hand emoji detector, we need to perform the following steps. First, we need to install the dependent libraries, which are OpenCV and TensorFlow. Second, we need to load the pre-trained models which have been trained on hand emoji data. Third, we need real-time camera feed to perform real-time hand emoji detection. Everything you need is available in the Kandi kit. Let's start by installing the Kandi kit. Check the description for link to the installable. This will set up a working sandbox application with all the needed prerequisites and resources. You can download the installer here, and you can also follow the instructions mentioned here to set it up. You can pause this video for now to complete the installation. Once ready, hit resume and we will jump right into building our own AI hand emoji detection. Hope you're all set. If you have successfully set up, you'll see this Jupyter notebook. Now, let's have a closer look at the Jupyter notebook. If we see the first cell, there are multiple import statements. So these are basically the necessary libraries and modules which are needed to run this notebook. Here, we are importing OpenCV, which is CV2, and Keras, through which we'll be accessing the model built from TensorFlow. Then we create a custom function called keras_predict, where we call in multiple other custom functions and also the predict function to give out the most prominent or the most prevalent emoji that has been predicted during the live camera feed. In the next cell, we create a function called keras_process_image, which is basically designed to resize and reshape the input frames that are captured during the live feed. In this process image, the image frames that are captured in the live feed are resized to the shapes of 50x50 and are adjusted in such a way to suit the dimensions in accordance with the training data on which this model has been built on. Then we have a get emojis function, which basically loads up all emojis that are available in the test set that is present in this particular location. These images, which are basically emojis, are loaded in memory to basically be displayed on the live feed. The overlay function helps to show the emojis live on the camera feed. This overlay captures the hand movements that we give in the live feed. Then we have the blend transparent method, which splits out the transparency mask from the color info of the images that are being captured during the live feed. This blend transparent is a submodule of the overlay function, which helps in creating background mask, overlay mask, after which we convert the images into a floating point in the range of 0.0 is to 1.0. Finally, for the overlay to be displayed, we add all these together to rescale it into an 8-bit integer image. Then we have the main method, which captures the live streaming video via webcam and displays the corresponding emojis. Here, we initiate the OpenCV to switch the camera or webcam on and capture the video. While the video is being captured, multiple images at different frame rates are being captured and multiple metadata are captured as well. Then these images are passed to the keres_predict method, which predicts the most relevant or the most prevalent emoji that is being shown and displays the most relevant one on which it has been trained on. Then we load the model here with model.load. There is an emojinator.hpy file, which is basically weights file of a TensorFlow trained model. We load the model and call the keres_predict function. The main function is being called. Let's go ahead and run this notebook to capture this in real time and display the emojis. For this, I'll restart the kernel and run all the cells. In order to show or demonstrate this hand emoji detection in real time, I'll go ahead and share the screen, which is the live web camera feed. Now we have a real-time camera feed. I'm going to go ahead and show some emojis for it to detect. Here we see that when each and every hand emoji is being shown, the model captures these images and then passes it on to the predict model and gives us the most relevant emoji. And also in the notebook, we can see that there are multiple values being displayed. So this 11 specifies what is the class of the emoji that has been predicted, and this value represents the corresponding probability. Great. You now have a working AI-powered hand emoji detector. In order to have more hand emojis to be predicted, it is advisable to train the model on new emojis. To add more emojis, you can go to the create gesture file and add more emojis. Then to train them, there is a train emojinator file which you can use to train the model with the existing emojis that is present in the gestures folder, along with the new emojis that can be captured on live while running the create gest file. That's it. Congratulations. You have a working model of a hand emoji detector that you can customize for your own application.
Hope you found this session useful. Using a Kandi kit is a great way to build AI prediction models. You can find the link to the AI-powered emoji detector kit and many other ready-to-deploy kits in the description. Head over to Kandi to build incredible projects on AI, blockchain, augmented reality, and many more. Try out our Kandi kits now. Hit subscribe and join us at the OpenWeaver community of developers to learn to build many more incredible projects. Thank you for watching this session. Until the next one, bye-bye.